Welcome to this lesson. We want to talk about the fourth factor affecting reaction rate, and that is catalyst. Consider the following observations. Enzymes are useful in the digestion of food we eat. Useful in digestion. Another observation, when preparing oxygen, in the laboratory using hydrogen peroxide, manganese 4 oxide is used to speed up the rate of decomposition of hydrogen peroxide. This manganese 4 oxide in this second scenario is known as a catalyst. In the first scenario, enzymes are also referred to as catalyst. Therefore, we want to recall our Form 1 chemistry knowledge that reminds us a catalyst is a substance that changes the rate of a chemical reaction without getting consumed in the reaction. It alters the reaction rate, but does not participate in the reaction, does not take part in the reaction. It doesn't mean that the manganese 4 oxide will react with hydrogen peroxide. No, it helps in the decomposition of hydrogen peroxide to give us oxygen gas and water. That is during laboratory preparation of oxygen gas. So we get that when some manganese 4 oxide is added to hydrogen peroxide, the reaction proceeds very vigorously. And at the end of this reaction, when the catalyst is removed by filtration, then dried, it is found to have the same mass. This manganese 4 oxide cannot be kind of showing a decrease in mass. It doesn't participate in the reaction. It only speeds up the reaction rate. This means that it is not consumed in the reaction. Catalyst speeds up the reaction by lowering the activation energy. That is the point. Catalysts lower the activation energy. This means that more collision will result in the reaction, and that is why they speed up the rate of reaction. This concept is of great importance in industrial and biological processes. The catalyst in the biological processes known as enzymes, and they help in increasing the rate of digestion among some other functions in the body. Modern vehicles are fitted with catalytic converters that is able to convert the carbon 4 oxide produced to carbon 2 oxide, to carbon 4 oxide, and even is able to change the poisonous sulfur oxide to non-poisonous oxides. You realize that in different industrial processes, there are various catalysts that are involved to help in the rate of manufacture. For example, in the Haber process, we use finely divided iron as a catalyst. Finely divided iron. In the contact process, we use vanadium 5 oxide as a catalyst. In the preparation of oxygen, we use manganese 4 oxide as a catalyst. So these are different catalysts used in different processes in the industries majorly. Now, in any reaction, there is usually minimum amount of energy required for a reaction to start. This is the energy we call activation energy. So, activation energy is the minimum energy required for a reaction to start. Reaction to start. And we are saying the energy that we call activation energy and is normally abbreviated as EA. Catalysts, like we have said, accelerate rate of reaction by lowering this activation energy. This means activation energy is low in a catalyzed reaction and higher in an uncatalyzed reaction. Most catalysts work by providing a surface on which particles can react. Surface on which particles can react. Increasing surface area increases the rate of reaction, and therefore when a solid catalyst is used, it is more effective when it is in liquid form. Sorry, not liquid form, but in powder form. So we are saying solid catalyst is very effective in powder form. Just like we said in our previous lesson that surface area increases rate of reaction. So the workability of this catalyst will also be higher when the catalyst that is solid is in powder form. Let's have diagrams to illustrate how the reaction is taking place with a catalyst and without a catalyst, and that is based fully in the study of the activation energy. So we'll have two graphs. That's the first one, and that is the second one. X-axis, Y-axis. This is Y-axis. This is X-axis. So we have reaction path and enthalpy. Reaction path. This is enthalpy. Enthalpy. So we have reactants. So this is uncatalyzed. Products. This is reactants. This is product. This is what we call activation energy up here. So, and that is for uncatalyzed reaction, where we have higher activation energy. Let's look at a case where we have catalyzed reaction. That is the space for the reactants. That is a low activation energy. This is catalyzed. Catalyzed reaction. And we have low activation energy. In both cases, we'll have what we call delta H, just like we studied in enthalpy. Delta H. So you can see there is a lowered activation energy when we use a catalyst, and this one is higher in the uncatalyzed reaction. We can have a general one joining the two. So by starting the y-axis, x-axis, this is our y-axis, yeah, this is this our reaction is a exothermic reaction. The general one, this stands for both exothermic, both are exothermic reactions where there is loss of heat. The energy of the reactants is that higher than that of products. Heat is lost. Then this second one is for general. I'll start with general exothermic, then general endothermic. So this is the reactants. Uncatalyzed, then catalyzed, products, reactants, so this is the activation energy of a catalyzed reaction. Then we have activation energy of uncatalyzed reaction. We have reaction path, enthalpy, and this is what we call exothermic reaction. Where the energy of the reactant is higher than that of the products. We also want to have the one for endothermic reaction. So these are reactants. Let's have the one for endothermic. Y-axis, x-axis, reaction path, enthalpy, So we'll have the reactants at lower level. Start by having the uncatalyzed. Then catalyzed. So we have their products, reactants, so we have activation energy, and this is also activation energy. So the uncatalyzed is longer, so this is the one for uncatalyzed. Then this is the one for catalyzed. It is lowered by the catalyst. So this concept is what you call the one in endothermic reaction, and that is all about the effect of catalyst in the rate of reaction that we've realized. Catalyst will always increase the rate of reaction.